Okay, lesson 49, the log function. So you need to know how to graph the log function. So we're going to learn to do it by graphing the exponential function. And since they are inverse functions of each other, then we can quickly just convert it. So what do I mean by that? So this is an exponential function. We know that. We know this is the, oh, I'm sorry, you can't see it. This is the exponential function. We call it the exponential parent function. And this is one that you need to have memorized. Okay? So, I know how to graph that. Okay? It goes through 1 on the y-axis, because when x is 0, y is 1. And when x is 1, y is 2. And I know it looks something like this. And I got 2 good points there, right? Okay? Now, if I want to pick 3 strategic points, I can turn this into a log function. Now, before we get started here, let's take the equation y equals 2 to the x and turn it into logarithmic form. So how do we do that? Let's see. Remember, this is the base and this is the exponent. So it's going to be log base 2 of y equals x. But whenever you do inverse functions, you change the x to a y and the y to the x. So I'm going to do this. So now I am going to graph this log function. Now I've graphed the exponential function. I'm going to take each of these points and reverse them and graph it. So instead of graphing 0, 1, I'm going to graph 1, 0. Instead of graphing 1, 2, I'm going to graph 2, 1. I'm going to also graph, just like a dotted line, like this, or a broken line, the line y equals x. Because it's going to reflect over that line. So if this is a line of reflection, then this one's going to come down like this, and then it's going to go out like that. This point, again, is 2, 1, and this point is 1, 0. Just backwards of those. And that's the way you graph that log function, by knowing it's the inverse of an exponential function. Okay, now, let's look at some log rules. Okay, we know that there is one log rule. If I say let m be b to the a, and let n be b to the c. Okay, so we're going to give them some values. Then I'm going to show you how this log rule is correct. So I'm going to take each of these and sub it in. So log base a of m, which is b to the a, times n, which is b to the c. I'm going to show you that that's equal to log base a of b to the a for m, plus log base a of n, which is b to the c. Okay, on this side, we know that we could rewrite that. I said a, but you know, these are supposed to be b's. I am so sorry. These bases have to match. There we go. These need to have like bases. Anyway, if I'm multiplying these two things, I can add their exponents, right? Log base b of that. I also already know that when the log base and the base of this expression are the same, the answer is just simply the exponent. Okay? Well, I know, again, if the log base and that are the same, that is just the exponent. Same thing here, and so they are equal. Now, how do you use that? So your problems might look like log base b of 3 plus log base b of 5. What is that equal to? It's log base b of 3 times 5, which is log base b of 15. Okay? Now, I just showed you how to develop that first rule. And in your textbook is very good explanation of how to develop each one of these. And you'll be asked to do that in homework. So I'm not going to develop every one of these. I want you to go to your book and fill in the rest, these two notes on the development of them. But I am going to give you examples of what they look like when you use them. So for this one, it might look like log base b of 4 minus log base b of 7. Now because it's minus and not plus, it's going to become log base b of 4 over 7, division. When it's plus, it's multiplication. When it's subtraction, it's division. Okay? And then for this one, if you had something like log base b of 6 squared, well, you could change that to 2 times log base b of 6. Or if you have this one, you can change it to that. So if you have a number multiplying to the whole log expression, it can become the exponent. Or again, you can flip it back out the opposite way. You're going to have lots of time to practice these. So let me just show you one that's sort of like a combination of things. So what if you have 2 times log base b of 3 plus 3 times log base b of 4? Well, this 2 is a multiplier to this log, so I can change that to an exponent, and the same thing here. So that's log base b of 9 plus log base b of 64. Okay? Now because they're both log base b and it's plus, I can make this log base b of 9 times 64. So that's log base b of 576. So you were able to take this expression and get it down to this one. Okay? I hope that's helpful.